to stimulate. Otherwise, it will not contract. And you cannot measure the pressure or the tension inside the muscle. So the amount of initial stretch or initial tension that you apply to a skeletal muscle, cardiac muscle is also a skeletal muscle. Before you start the contraction is called preload.
Preload?
Preload. PRE, preload. The initial tension you should apply, this is called preload. See, in this system, which is called isometric, the length doesn't change. Isometric tension and isometric contraction. Before contraction, two ends of the thread should be stretched. If they are loose and if you apply a stimulus, it doesn't contract at all. You should stretch it before initiation of the contraction or stimulation. This initial tension, stretching the ends of the thread, before contraction is called preload. Preload, this is, you're talking
This
about...
is stretching is preload.
Yeah. So the initial tension you applied before initiating the contraction. In cardiac muscle cell, which is a striated muscle like a skeletal muscle, this initial tension in cardiac myocyte is called end diastolic volume.
Sorry?
End diastolic volume or end diastolic pressure, both. So preload in heart is equal to end diastolic volume or end diastolic pressure.
It's not called preload, it's called...
No, you can also say preload, name preload, or end
and
diastolic volume pressure. Here, if you have isotonic contraction, you see, we connect the panel weights here. The load that the skeletal muscle
is lifting.
lift is called afterload, which is analogous to aortic pressure. Because see, left ventricle wants to contract. This load in the aorta is just like weight of panel base here. The pressure that the left ventricle should exceed, should overwhelm during contraction is aortic pressure, which is called the afterload.
So after loading,
Preload.
after load,
If afterload is blood pressure or aortic pressure or peripheral vascular resistance.
second, after loading cardiac muscles, it is after load. It is aortic.
Blood pressure, aortic blood pressure. And diastolic volume or diastolic pressure equals to
The preload.
preload, and aortic pressure is afterload. Now listen to me. Suppose that the left ventricle wants to contract against a stenotic aortic valve or in a hypertensive patient. Suppose that a patient is suffering from aortic valve stenosis or hypertension. So here in this case, the afterload is increased. The amount of work that the left ventricle should be performed to overwhelm to the aortic pressure would be very high. the tension should also be very high because the pressure inside would be very high. What about the radius? In order to see the amount of oxygen that is used in the heart is directly proportional to the wall tension. When the wall tension is high, the amount of oxygen that is used is also high. So, in order to counterbalance this high wall tension, this is the wall of the left ventricle. You see, cardiac myocyte is added parallel to each other, and the wall thickness will be high. When the wall thickness is high, the volume is the volume. The volume inside the left ventricle. So if you add more myocytes here, parallel to each other, the volume will be decreased. When the volume is decreased, the radius is decreased. When the radius is decreased, the tension will also decrease. The amount of oxygen that is used is reduced. This is one mechanism to reduce wall tension and oxygen consumption. When you reduce the volume, the amount of blood that leaves the left ventricle will also be reduced. The amount of blood that is coming into it is also reduced, and the cardiac ejection fraction or contractility will also be reduced. This is how we use the Laplace, your question, your Laplace formula. This type of wall thickness is called hypertrophy. Concentric hypertrophy. We have two types of hypertrophy in the ventricle. Concentric means added myocytes parallel to each other. Concentric hypertrophy, which is usually seen in hypertension or aortic valve stenosis, reduces the volume of the left ventricle, but decreases the wall tension and the amount of oxygen that is used.
Hypertension or aortic valve?
And aortic valve stenosis.
What is that?
Stenosis means narrow opening in the aortic valve. There is another type of hypertrophy, you see, adding in parallel or adding in series. See, if I want add the myocyte in series, the volume is increased.
How?
Because you see, in series, not in parallel. See, the left ventricle cannot contract effectively. See, here in this form of hypertrophy, the cardiac myocytes are added to each other in series. When adding the myocytes in series, the volume inside, the wall thickness is reduced. The volume is increased. This is called eccentric hypertrophy. In the previous version of Guyton, it doesn't mention in the book, but in the new version it is mentioned. And you cannot understand the term. So we have two types of hypertrophy. Concentric, which added myocytes in parallel, reduces the volume, and in series, which added the volume and decreased the
Myocytes are in series.
increase the volume Hmm? When the left ventricle cannot contract effectively,
The wall thickness.
the amount of blood that is left at the end of systole will be increased. So the volume inside the left ventricle will increase, will also be increased. This is called eccentric hypertrophy. So we have two different types of
In
hypertrophy.
eccentric, thin walls.
Pardon? We have
Thin walls. Thin walls in eccentric.
Wall thickness decreases.
thin
yes.
walls.
Yeah.
Thin, yeah. In hypertrophy, we have thick wall. So eccentric, concentric.
In what case does the hypertrophy occur? Like
Both
why,
cases are hypertrophy.
why?
Hmm?
Why should myocardium will increase?
Why should do we have hypertrophy?
Yes.
Because this is a mechanism of, in order to decrease the wall tension. In concentric, added cardiomyocyte in parallel to each other. When in eccentric one, when the amount of blood that is left in the heart at the end of the story is increased, because the heart cannot forcefully contract. When the heart cannot contract, then more blood is left. This is called eccentric cardiomyopathy. We have two types of cardiomyopathy. One, concentric, and the other one, eccentric. See, in eccentric cardiomyopathy, which the left ventricle